Hi all, my name is Richard Nugent. I'm an economist and the lead developer for the HEC FDA program at HEC. In this series of videos, we take a look at some hydraulic relationships that we define in the FDA program. And in this video, we are studying the interior-exterior stage function. An interior-exterior relationship defines a relationship between the water surface stage on the river or exterior side of a levee and the stage in the floodplain or the interior side of the levee. This relationship is necessary if the stage and the interior will not reach the same stage that is overtopping the levee. This may be due to floods that result in stages near the top of the levee overtopping as designed in a safe and controlled manner, or a flood hydrograph volume not sufficient to fill the floodplain to the stage equal to the top of the levee. In either case, the relationship must be developed from hydrologic or hydraulic analyses external to the FDA program. If the relationship is not specified, the assumption is that the floodplain fills to the stage in the river, represented by the exterior stage discharge function for the reach, for all events that result in stages that cause levee failure or are above the top of the levee, usually overestimating damages and undercounting benefits. We may use an interior-exterior stage function to simulate water passing through alluvial fans where water spreads rather than rises. We may use this function to simulate water passing through perched channels in the cases that we have levees, flood walls, also in the case of coastal storm surge barriers. Observe Figure A on the right from Engineering Manual 1110-2-1619, depicting a levee on the left side of the bank holding back flood waters. The depth of flooding at point B is 0 and will remain 0 even as floodwaters increase up to the height of the levee as illustrated by the dashed red line in Figure B. However, if an interior-exterior relationship is not defined, then the flood depth at point B is assumed equal to point A the moment that the water surface elevation overtops the levee, as illustrated by the end of the dashed red line in Figure B. So this is sort of an extreme assumption that we make. And the interior-exterior relationship also helps us to define cases where perhaps the water surface elevation at point B is, or the depth at point B is actually not 0 when the water surface elevation at point A has not yet overtopped the levee. In any event, so as not to overestimate damages and to capture all the benefits from levees, flood walls, storm surge barriers, among others, the interior-exterior stage function really should be defined. To define an interior-exterior relationship, open the Levee Features window in the HEC FDA program and select Interior-Exterior Relationship. The interior-exterior relationship window will open, and for each exterior stage in the channel, enter an interior stage in the floodplain. Some final notes about the interior-exterior relationship. There is currently no uncertainty defined around the interior-exterior relationship, and this relationship is tied to the levee module. Both of these things are changing with the release of HEC FDA version 2.0. If you have any questions, please feel free to email me, Richard Nugent, or post your questions to the discourse discussion board.